Hello, welcome back to the Untitled Where I Fix Stuff. You're looking at the underside of the tuner chassis for the Sentinel portable TV. I have not done anything with this yet. See all the old paper capacitors are still in there, and the selenium rectifier, the nice bright orange one, is still down there. So this has two separate B plus, separate levels of B plus, I guess you could say. So the transformer winding for the B plus comes out of the transformer and is rectified by this selenium rectifier to produce one level of B plus. So I think that's around, I can pull up on this schematic, but I think it's around like 150 volts or something. And then that same transformer winding goes up to the tuner chassis where they have a voltage doubler to get the second level of B plus, which is around like 250 volts. So there's two separate levels of B plus, and I don't know exactly why they separated them, because that higher B plus from the picture chassis actually feeds back through the cable back into this chassis and provides that higher level B plus to a few things. So why they didn't have all three selenium rectifiers in the tuner chassis and generate all the B plus here, and then just transmit that higher B plus over to the picture chassis through the connector to power, the B plus in the picture chassis, I don't know. Unless they were just trying to like spread out the heat from the power resistor, because you see there's quite a few power resistors down here, and there's another power resistor in the B plus supply for the higher B plus. So maybe they were trying to separate the heat out a little bit. This looks pretty hacked up. I'll have to take a look at what's supposed to happen there. You can see there's a canned ohm that is not connected to anything anymore, just sitting down there at the bottom. So I assume this conglomeration of resistors replaced that. But I'm looking to cleaning up a little bit, because see they've got two in series there, and then another two in series there. But they've taken power from the middle of this, from the top end of this, and it looks like from the bottom of that. But the canned ohm only has two sections. So right now we're taking power, we're using three resistors, but the old canned ohm only had two, because there's nothing connected to the middle point of these two here. So it's essentially three resistors. So unless there was like a resistor going from here to the canned ohm and then two canned ohm resistors, I'm not sure, but I'll have to check it out on the schematic. So that's something to look into. And the first thing I'm going to do though is replace the capacitors up in this area, because this area right here is the video amp and the sync circuit. And remember from last time, there was quite an issue with sync. It would just barely sync at all. And even once it did sync, then it would drift out right away. So first thing I'm going to do is recap this up here and see if that changes anything in the sync circuit. And in other notes, on the picture chassis, I did check some of the resistors in the vertical circuit, because I still think the vertical height should be higher. And I found some that are not hugely out of tolerance, but they're moderately out of tolerance. So I'm going to replace those while we're at it and see if that gets us a little bit more vertical deflection. Then I'd be somewhat more comfortable with that. But so let's get to work here and see if we can accomplish anything. So as you can see, we still have some sync issues. Sometimes it'll lock in and not look too terrible, but you can see how it's like distorted over here. And it almost looks like it's like some filter hum, because see how it kind of like rolls up the side. There is still one old electrolytic in the voltage doubler. I think I might try changing that and see if that goes away. So we're losing sync again. You see, when it loses sync, the retrace lines come back. So now the retrace lines are gone. That was pretty well synced horizontal. It looks like it's somewhat off though. So yeah, I think that's what I'm going to do. I'm going to change that other filter capacitor in the voltage doubler. See if that takes away this AC hum. I don't think that the lower B plus that I didn't recap yet comes over to this chassis. I think just the higher B plus from this chassis comes over to that chassis. So I'm not sure that the non-weak power supply in the tuner chassis would be affecting this ripple here. But if replacing that one last filter capacitor in this chassis doesn't help, then I will redo the power supply in the tuner chassis as my next step. You can see what I've done here. I did redo, but I did have one tonal strip mounted down there. Turned out it was too small for all the capacitors, so I took it out and put in a longer one. And then I've got the 3 filter capacitors that were in that 3-section can. Plus this one used to be a capacitor up in this bracket here. I believe that's the cathode bypass for the oscillator. So I mounted that down there too, just ran a wire down to it. And then so this capacitor right here, you can see there was 4 legs sticking out. And that's what used to be these 3 here, and then there's one more down there in the voltage doubler that I didn't replace yet. So I'm going to do that next. You can see I replaced these resistors here. It didn't help a whole lot as far as the vertical voltage. That's the way that they had it before. They just had 2.4 meg. I went with 2.2 meg. 2.4 meg resistors in series, and the reason for that is because of the high voltage drop across those resistors. If you just use one, like 4.7 meg, it could potentially break down under such high voltage. There's I think like 600 or 700 volts across that or something. So I just did the same thing since that's what they had, and it seems to be working fine so far. Just still some sync issues and I think some power supply issues coming in here. So let me change that and see if there makes any difference. The audio is fine when it works. It was working. Oh, there it goes. So there's no filter hum in the audio, so I'm kind of skeptical that there would be filter capacitor issues on this chassis, at least not yet. This capacitor is going to start failing as we play around with this, but if there were issues with that secondary B plus supply in the tuner, I would expect to hear it in the audio, and I don't. So either way, I'm going to keep playing around with this, see if I can get this to be somewhat better. Alright, so I've been playing around with this thing for a while, trying a couple different things. Not sure where I left off last in the video, but I think there was like some ripples in the picture, like it wasn't like straight on the sides, and like vertical and horizontal sync would be messed up. And one thing that I have discovered, which is not the root of all the problems, but is somewhat probably related, I've got the horizontal oscillator tube pulled out right now. So if I turn the brightness up just a little bit, you can see we've got what would be a vertical line if the chassis was oriented properly. Right now it's a horizontal line. So I'm not going to turn the brightness up much, just barely enough to see, because I don't want to burn a line in the CRT. Now, let's see if I can do this on camera. If I turn this up like I had it for testing, you'll notice that the line gets lumpy. See, before it was a nice straight line, and now see how there's dips in it? You can see that. I'll put it back down, and you'll see it's a nice straight line again, pretty straight. Maybe like a little tiny bit of ripple, but not anywhere near as much as what it is when I turn it up, and you can really see it then. Yeah, see how it's pretty straight here, and you could definitely see the ripple in it before. Let me turn this down before I burn a line in. So I think that was part of the issue. It's definitely not the whole issue, but that was definitely confusing me somewhat while I was experimenting here. Let me pop this tube back in. I have the sync tube pulled out right now because I'm experimenting with that. So I'll pop that back in, let it warm up so we get our horizontal back. We get our horizontal back now. It's going to be hard for it to sync because the sync tube's not in. Let me see if I can bring it a little bit. So it's still not perfect. You can see, well, there's still some ripple in it, so I think I still got some hum coming from somewhere. Let me pop one of these sync tubes back in just so we can get a good sample here. Sync tubes back in, so hopefully we'll get some sync soon. So I think the reason why that's happening so I think that it gets a little bit more just sort of once the sync tube's in, so I think there might be some issues in that circuit as well. I did replace, so all the capacitors and all the chassis are replaced. All the paper capacitors and all the electrolytic capacitors are completely replaced. I did replace some out of value resistors in the vertical oscillator circuit, and I think it helped. I got something arcing for some reason. I replaced some out of value resistors in the vertical oscillator circuit, and I think that helped somewhat, but still not perfect. You can still see how the sync is not working. So I have ordered some replacement tubes for the sync tube and the video amplifier. They're the same kind. It's working now. I have to look into what's arcing now. I wasn't doing that a minute ago. You can see how we still got, a significant ripple here, which was not there when I pulled the horizontal oscillator out. So there's definitely noise getting into the horizontal oscillator somehow. I really have to look into what the heck is arcing now. I did replace the dual knob capacitor that was underneath. I did an experiment where I cut the wire off the dual knob capacitor and tacked in like a 0.001 capacitor at 6,000 volts. And when I did that, I must have stressed the wire a little bit too much going to that dual knob capacitor, and the insulation burned through. So I ended up just removing that wire. Probably pull this up and show you what I did. You can see, so the dual knob capacitor is right up. See, the dual knob capacitor is right up in there. You can see that little blob there. So they used to have a wire running from a hole underneath the high voltage area, a wire running all the way up through these little clips here up to that. And when I took the wire off of here and put the capacitor on, I must have pressed it a little bit too hard against this clip, and it burned through the insulation and shorted out against this clip. So that wire is gone. I replaced it with a 500 picofarad capacitor underneath the high voltage oscillator board, which I think might be what's arcing now. I have to take a look into my lead dress there. Might have something a little bit too close to ground that's arcing over, so I have to take a look into that. But so I think we definitely got issues in the sync circuit and potentially some issues in the horizontal oscillator circuit. What I can do, actually, let me turn this brightness down. And before I had pulled out the horizontal drive tube, let me pull out the horizontal oscillator tube and see what our line looks like then, if it's straight or not. Not quite as straight, but it's pretty straight. It's definitely straighter than the side of the picture is. So yeah, it could very easily be noise fed through from the sync circuit if that's not operating properly. So I'm going to take a look at the resistors in the horizontal circuit and in the video amp and sync circuit. And like I said, I do have replacement tubes for the sync and the video amp. And the main reason why I got replacement tubes is there's something up with this tube. This is the original sync amp tube that was in there. Let me pop it back in and I can show you what the issue is. So you can see the tube back there, and you can see how bright it is. Now the tube that's next to it, this one right here, is the same kind. I think they're 6AU6. Yeah, 6AU6. And you can see how the one next to it just has the, the nice red glow at the bottom, but the one in the back is super bright. So I think something like either the filament shorted to itself or something is messed up with that particular tube. So I just ordered a couple of them. I'll replace both the sync tube and the video amp. Just see what that gets us. The sync tubes, the tubes that I'm using now actually are out of another TV. I just popped them in and didn't really make a whole lot of difference really. So, and either way, I want to put these other tubes back in the TV they came out of. So that's why I've ordered replacements for that. I'm having trouble putting this tube in today. There we go. So I think we're getting a little bit better, but there's still plenty of issues that need to be worked out yet. So I was going to do a little bit of update with that. Oh, I don't know if I mentioned my theory behind the distortion when the chassis is tilted upright. I'm wondering if and somehow the magnetic flux from the transformer is like coupling into the deflection somehow. I don't know if that would be possible or not, but that's my best theory as to why the horizontal line, well, in this case it's horizontal, but in reality it would be the vertical line if the chassis is oriented correctly. While the vertical line is straight in this position, but wiggly in the upright position, is because that the only difference that I can see really is that both the oscillators and the neck of the picture tube are significantly closer to the power transformer. Now, when this is mounted in the chassis, they would not be that close. This chassis, the tuner chassis, basically takes up the entire bottom of the cabinet, and this would be mounted sideways, like up here on top of it, not like super close like I had it. So we won't know until we get it back in the chassis whether it'll be fine or not, but hopefully it will be. So anyway, I just want to give a little update of where I am now and a couple of things that I've tried, and I think that's a very interesting thing that I've discovered there. Kind of confusing initially because, when you take the horizontal oscillator out, then like the only voltage source supplied to those plates would be from the high voltage. So actually I can show that on the schematic. Let me show that. Pull up the schematic here. Hopefully I'm not going to get a copyright strike from this. Assuming YouTube's copyright thing can't recognize twitching pictures. Hopefully anyway. Okay, so what we have is... So this is the horizontal output right here. They call it a horizontal amp. And then this half of the tube, which goes off the page, is the horizontal oscillator. So the high voltage, see if I can use my pen here. The high voltage is right here. So if I show what I'm doing. So this is our high voltage point is right here. That comes out of the high voltage rectifier. And we got some resistor dividers, the horizontal centering control, which is essentially acting as another resistor divider, and the same thing with the vertical centering control. And then these lines here, see this one, go up to the horizontal plates on either side. So these are our two horizontal plates right here, and they go up and over. This is not drawn properly here. So I'm showing it. This right here looks like this line is going right into the power transformer, which it is not. That would be very, very bad to do that. So someone must have had a lazy day that day when they drew that out. But that is not the same line. This line goes up and over to that capacitor, which then goes into the plate of the horizontal amp. So this side should have, I think they say like 5800 to 6000 volts or something like that on it for the deflection. And then same thing, this line here goes up and over to the capacitor, and then that goes into the other plate. it's kind of like a differential there. So like on one side it's high, the other side would be low, and then like they balance out as it gets to the center of the screen, and they go the opposite way as the deflection goes across the screen. So basically what has to be happening for that line to be squiggly is because there's going to be no signal coming in here, and you might be saying like, oh well, these lines are still connected here, but I did disconnect both of these capacitors for testing, and that would isolate these lines so that there is no other signal coming into these except through the voltage divider from the high voltage. So, and there doesn't seem to be any difference whether these capacitors are connected or disconnected, which would make sense because this line here should also be filtered. It does have capacitors on it. Apparently I can't scroll when I'm in pen mode. That's nice, Apple. Just makes me draw more. Anyway, so let me get rid of these. Can't scroll while you're in pen mode. Anyway, so basically what I'm trying to say is these two lines, this line and this line, should be completely stable when there's no signal coming in, because their only power source is voltage divided from the high voltage power supply. See, one is the center point of these two resistors, and the other one is the center tap of the horizontal centering control. So there should be no other signal source coming onto these lines. So the question would be, how can one of these be at a different potential than the other one? And that's not constant, that's varying, right? Because like at some points the line is in the center of the screen, but then as the vertical changes, you get a bump. So at like somewhere around the center of the screen then, let me phrase that differently. The horizontal line, or if the chassis is oriented correctly, it would be a vertical line, is in the center of the screen. And basically what's happening is the horizontal is fixed, right? Because there's no signal coming into either of these plates. The vertical, however, is still varying because the vertical oscillator and amp is still running. So basically you just got a slow trace going from the bottom, or from the top to the bottom continuously. Now as the vertical is tracing down the center of the screen, the line gets a little blip in the middle. I'm sure you saw that. Hopefully you saw it anyway. So what has to happen for that to be the case is, as the vertical is tracing, the voltage on these plates has to change. So one plate has to have more or less voltage than the other in order to cause that blip, in order to cause that line to move from right to left as the vertical is tracing down the screen. So the question that I was having was, how is that possible? These are completely disconnected, and the other end of them is connected to a fixed point, a fixed voltage source, which is the high voltage. And even if there's noise on the high voltage, it would cause both of the plates to vary equally because there's no load on them. Like there's not any current flowing from these plates through the tube. They're just deflection. So even if there was noise on the high voltage, which is this point right here, the question would be, how can they be different? Because they're both powered from the high voltage, and there's nothing putting any other signal onto them, nothing pulling any signal off of them. So what could cause a difference between these two plates? And the only answer that I could come up with that would do that is that somehow there's some noise or some magnetic flux from the transformer coupling into either the tube or into the wires going to the tube or something like that that would cause that. And the fact that it's different, when it's closer to the transformer and it goes away when it's away from the transformer, would seem to be a confirmation of that. So that's my explanation of that, or I guess my guess. I have no evidence for it, but it makes sense to me, so we're going to go with it. And assuming that, if that is correct, assuming that the tube is far enough away from the transformer when it's mounted in the cabinet, which hopefully it will be, hopefully it shouldn't have any effects during normal operation. So what I'm going to do is check out the resistors and the horizontal oscillator and the sync and video amp, and see if there's anything that stands out there. I think I checked those before and there wasn't anything like super off. We're going to check them again, and anything that's just like a little bit off, I'm going to replace because we definitely still have issues here. I would like to try different tubes for the vertical and the horizontal, but unfortunately these are 6S and 7 tubes. And I looked up the price of 6S and 7 tubes, and they're like 40 or 50 bucks a tube because audiophiles have decided that they want them. So right now we are not buying new tubes for the vertical or the horizontal amp. Vertical or horizontal oscillator, horizontal amp. The vertical amp is a 6SL7. I was able to find a moderately used, cheaper replacement for that. Didn't seem to make any difference. Of course, that tube could also be bad because it's not a brand new tube. But anyway, I'm going to start with checking those resistors and just see what I can come up with from there. So I'm experimenting with this a little bit. You can see that right now the horizontal is synced. Vertical's not, but that's just ignore that for the minute. Now this is with the sync tube pulled, or the sync separator tube is out, and also I've disconnected the resistors that come from the sync separator that feed into the horizontal and vertical oscillator. And even with that, you can see that the horizontal is still synced. And you know, it's got a little tiny bit of a ripple in it, like a little bit there. It's not a huge thing. Like we had, like before, we had like quite a bit, and also it was like so bad that it was losing sync altogether. But now it's like synced all the way up the screen. Let me see if I can play with the vertical here a little bit. That's vertical height. Because without the sync, it's going to be hard to get it to sync. So you see, you still got like a vertical linearity problem. Like how it's more stretched out, and then it's kind of like squished there, and then like it's squished up there a little bit, and then as it rolls, the linearity changes. So that's another issue. Right now, I'm mostly focused on the horizontal at this point. Now, watch what happens when I put the sync tube in. So the sync tube is now in, and it should be warming up. You can see that we've got some horizontal changes happening. Now, see? Now you've got this giant kink in the picture right there. And it's losing sync at that point. It might be the retrace though. But look at this giant kink right there that only comes up once the sync tube is in. Not quite sure what that means yet, but it's definitely interesting. And it's definitely helping to isolate the problem. So it looks like the horizontal oscillator itself is actually not working too bad, and that some of the issue, is coming from the, the tuner chassis with the sync, video amp or sync separator or something, seems to be causing this issue. So, going to look into that. Also notice that we still don't quite have vertical sync, and our vertical linearity issue seems to actually be getting worse. So yeah, it's an interesting development. I'm going to continue to work on figuring that out, why that's happening. Something else that I wanted to note is, if you can see it or not, but there's some writing on the chassis here. And some of these tubes, like it says 6AS5 poor, 6SQ7 poor, these two tubes are marked as poor. So it looks like some of these tubes may not be in the best shape. The video amp is marked as poor. I'll probably just try swapping that out too. I think one of the, this tuner tube here is marked as poor. Not sure if that's going to cause this. I kind of doubt it, but anyway, I'm going to keep playing around with this and see what I can figure out. But this is definitely interesting that this kink here only shows up with the sync tube in. Another interesting development, let me dial this back in. I've reconnected the resistors that go to the sync circuit, but I still have the sync tube out. So you can see the horizontal looks, pretty synced. Vertical, still not quite synced. Still got the vertical linearity issue. But watch what happens when I turn the contrast up. Right now the brightness is all the way up, which you can't see because it's blinking. set this to. Okay, so horizontal sync, brightness is all the way up. Now I'm going to turn contrast up. You see the vertical gets really messed up now. And horizontal is like messed up as well. So everything is all whacked out when I turn contrast up. So there's bright lines here. Everything's just really whacked out. Turn brightness down. And it goes, still got the vertical linearity issue, but it's, it's mostly watchable now, except for the sync, but, the picture is there and recognizable. Contrast up. Looks like complete garbage. You got like vertical fold over and everything. You can even see how like the picture like rolls around over on itself. So that's interesting. Something that I did notice. Let me pull up the schematic here. Let me see. So over here in the high voltage circuit, you can see where the high voltage comes in from the rectifier to this point. And we've got a bunch of resistor dividers and the horizontal and vertical centering control. And I've also got this resistor divider network here. You can see they've got a 2.2 meg and then a tap off for, I'm assuming this is the second anode, like high voltage acceleration anode, because it will be the highest voltage of these grids here in the picture tube. And I got another 2.2 meg, and then continues on the divider, and then that goes in to feed the vertical circuit. The vertical output tube is fed from this massive resistor divider here. You can see it goes down, then it goes back up here, and then up into the vertical circuit there. I have replaced a couple of these resistors, like I replaced these two, and then I replaced this one. There's the focus control there. Anyway, my point is that you can see here where they got the 2.2 meg and the tap for the high voltage acceleration anode, and another 2.2 meg, and then continuing on. But that's not how this set is wired. I checked. This tap here, this second anode, actually goes right to this point here, right on the high voltage. So what I'm starting to wonder is, if changes in the picture, which we've lost sync again, so no sense looking at that, but I'm wondering is if changes in the, variations in the video signal, which would cause like a slightly varying load on this anode here, as you let more and less electrons flow through the picture tube. I'm wondering if that is affecting the high voltage. Not sure if that would really be the case, or if that was the case, if that would cause this symptom. Because even if this was connected down here in this resistor, across this, on the other side of this resistor, it would still be in the chain of supply to the vertical output. So if this voltage is varying, it would still potentially affect the voltage at the vertical amplifier. And that's at the end of that resistor divider. So what I think we're going to do as an experiment is just connect that the other way, connect that into this resistor divider here, and just see if that makes any difference. The way that they've got this set up now is, instead of this, I think they have just like, instead of these two resistors here, I think they just have like one 2.2 meg tacked in parallel with these other things. So it's kind of weird. So I might try and wire that as shown on the schematic and just see if that has any effect at all. I think that's a very, very curious effect that we're experiencing now. So I'm probably going to do that and just see what happens. And if nothing happens, then look on to other problems. So I put it back in the cabinet just to see what would happen. As you know, before I demonstrated how the location of the picture tube, or at least the picture tube chassis, with relation to the other chassis was causing some weird effects in the picture. So I put it back in just to see what would happen. So you still got some sync issues occasionally. You still get these white lines. So I just wanted to find out which issues were real issues and which ones were not real issues. So the sync is definitely a real issue. You see, turning the vertical control just a little tiny bit knocks it out of sync, which shouldn't happen. It should be stable for a much wider range. You see, it looks like we might have some. Let's see, there it goes again. So we got some vertical linearity issues. And see, now when it goes out of sync, now the top of the picture looks good because it's not folded over anymore. But once it's back in sync. See, we got that non-linear issue back at the top again. So that's definitely a real issue. The contrast all the way up and brightness all the way up is definitely a real issue. I wonder if that's something to do with the video amp, because the contrast adjusts the gain on the video amp. So when I turn it down, it's not as bad. When I turn it up, it's definitely worse. I'm also wondering, if we can get sync again, is, I can't really see it here, but sometimes when there's like a bright spot in the picture, it causes a dip in the vertical. And I feel that the vertical's like rolled right over on top there. So definitely issues with the vertical amp. So I'm gonna have to look more into that. Let me turn that down. We got a copyright strike. So contrast up causes issues. So right about there would be almost watchable. How good does that look in the camera? That looks, you know, it could be watchable like that, but I'm just not really satisfied with it. I think that you should be able to do this without causing issues. So you know, there's a bright spot. Well, you don't see. But sometimes when there's like a bright spot in the picture, the vertical will actually like lose a bit of its deflection. So I'm wondering if that's like depleting some of the high voltage, because the, as I showed before, the high voltage powers the vertical output tube through the resistor divider. So if the high voltage drops, you could lose some, you lose both vertical and horizontal deflection. But what really bothers me is this sync. And I only have one original resistor left in the vertical circuit. With something else that I don't know if I mentioned this before, the vertical circuit in here doesn't follow the schematic, where they've got the vertical linearity control wired in, and the vertical linearity control, additionally, if you adjust it, like this is it with all the way at one of its max, one of its endpoints. Stupid sync, that was horizontal, that didn't help. Anyway, this is with the vertical linearity all the way at one of its endpoints. If you turn it if you turn it down from that endpoint, all you get is vertical fold over. So there's still convinced there's something messed up with that. Like the vertical oscillator should not be this touchy. Yeah, so I did replace all of the resistors in the, I think there's one original resistor left in the vertical circuit, but all of the, like the vertical integrator and all that stuff, I replaced all the resistors in there. So the sync pulse is definitely making it to the vertical circuit. And you can see we have some sync, but it's definitely not good. Like this should not happen like this. See, now horizontal is getting distorted as well, somewhat. But interesting that you can make like individual scan lines go out of sync. vertical height, not the right knob. So interesting. See how like just those scan lines lose sync. If I turn it a little bit, then they're back in sync again. I find that interesting that that like individual scan lines would lose sync and not the whole screen. So I'm wondering like if when I do that, if the horizontal oscillator is like just on the verge, or we're not just on the verge, but is away from its desired frequency, and if the sync pulses get weak, like right in for those scan lines, then it might lose its sync because it's trying to run at a different frequency based on the setting that I have on the control, and the sync pulse isn't strong enough for those lines to bring it back into the correct frequency. I'm wondering if that's the issue there. Either way, I'm pretty sure that would be a issue with the sync circuit. Still not satisfied with the sync circuit. I think something's off there based on things like this and based on the vertical losing sync. Could also be issues, I mean, like the reason why the vertical is, maybe one of the reasons why the vertical is losing sync is, it could be that as the tube warms up, it tries to drift a little bit. I might try and make some modifications to the vertical linearity circuit to make it more like what's on the schematic, just to see if that makes any difference, because vertical linearity is like a completely useless adjustment on this TV right now. This is at its one maximum, and like, well, it is, pretty linear, it's still not the best. And like the ideal adjustment should be like in the middle of the control, I think, not at one extreme. But other than that, like when it's in sync, it's not that terrible. The retrace lines are retrace suppression is working. It's mostly watchable, so you got a bit of vertical fold over here. So I think that starts to come in as it warms up, get that vertical fold over. So could be a bad 6S and 7 in the vertical circuit. If that's the case, we're just going to have to live with it because I'm not paying $50 for a 6S and 7. That's just ridiculous. So anyway, just wanted to give a little update of like where we are, and like I said, it is almost watchable when it syncs, but definitely still plenty of issues left here. And I also wanted to test out and see, what issues are still present when it's back in the cabinet. And it looks like most of them are still present. Sync issues and the vertical fold over are still present when it's back in the cabinet. So I'm going to take it back out of the cabinet and see if I can figure out why. Okay, so you can see down here what the vertical linearity circuit is supposed to look like, right? So we've got the plate of the second triode and the 6S and 7 that's fed by a 470K resistor from B+, and they're taking the signal off of there and feeding it to a 0.1, which is connected to another 0.15 that goes to ground. And then they also got this 100K resistor going to the vertical linearity control. And then from the center tap of these two capacitors, they've got a 0.1, which goes to the other side of the vertical linearity control, and then a 0.2 coming from that point through 1 meg resistor to the high side of the vertical size control. And then the other side of the vertical size goes to 100K to ground, and they're picking the signal off of the vertical size control wiper to feed up into the grid of the 6S7 vertical output tube. This is what the schematic chart is supposed to be. This is what I actually found in the set. So you can see here's that plate of the second trial. They do have the 470K feeding it from B+, but they have a capacitor from this line directly to ground. And they got another capacitor going to a 1 meg with another capacitor going to the vertical linearity control. And then the wiper is connected to ground. You can see here the wiper of that should be connected to a 100K, which is connected to the plate. But instead they've connected the high side indirectly to the plate through this resistor capacitor network. And then the wiper went to ground, and then the other side is just floating, which is correct as per the schematic. One side of that is supposed to be floating. And then the vertical size, high side, they've got going to the other side of this 1 meg. The vertical size is supposed to be going to, yes, one side of a 1 meg, but basically what they've done down here anyway is from this point, they've added that capacitor and then the vertical linearity control. So quick drawing there. Is basically how they've got that attached. So yes, there is supposed to be a 1 meg going to a capacitor. And yes, that one side of that 1 meg is supposed to go to the high side of the vertical size control, but there is not supposed to be this thing here. Just supposed to be 1 meg, to vertical size, and for some reason they've attached the vertical linearity there, which is not supposed to be there. So that's, like, everything is just weird here. Additionally, you can see on the other side of the vertical size control, we've got this 100K to ground. Well, they've just put the other side of their vertical size directly to ground without that 100K in there. So could that be the reason why we don't have as much vertical reflection as I think we should? I'm not sure, but I think I'm going to do some rework there and just play around with that a little bit and see what happens if I rewire some of that to be closer to the schematic. What they've got is a much simpler circuit, but given that we have issues there, I'm kind of curious to see what would happen if I go back to exactly what the schematic has, or at least make it somewhat closer to the schematic has. I think for starters, I am going to add that 100K back in the vertical size and just see if that increases our vertical size at all. Because I think we should have more vertical size than we do have. And I'm probably going to connect the vertical linearity closer to where it should be. Maybe I'll add this 100K resistor in there going to that, and may as well just add all these capacitors in there. It shouldn't be that big of a deal. I don't have any 0.15s. This calls for 0.15 there, so I might try 0.1 or 0.22 and just see if that gets us somewhere close. And since it has an adjustment here, hopefully it shouldn't be too bad if I go with a slightly different value capacitor. What they have is absolutely nowhere near what it should be, and that does function, it just doesn't function very well. So hopefully if I get this, somewhat closer to what it should be, even if that one capacitor value is out, hopefully it'll be better than what we have now. But so yeah, that's interesting. I'm not sure why there are so many differences here. Some of the differences are called out. Like if I go up to, so if you go to here, let me just turn this sideways, let's see. So if I go to here, you can read some of the notes there about differences between the chassis. And they do mention out, let's see. Yeah, picture tube chassis stamped 20E374B have separate 0.001 microfarad 6,000 volt capacitors. No, my pen is working for some reason, even though I didn't activate it. Have separate 0.00 microfarad 6,000 volt capacitors. C22 and C22B also have a separate 1,000 ohm or 100,000 ohm resistor R42. So this is close to what we have. I think I mentioned this before, where the parts list specifies the high voltage capacitors as one single unit with the 100K resistor. I don't know if that was supposed to be a couplet or what. But what we had was one oil-filled capacitor under the high voltage board with a separate 100K resistor, like they say. And then we had a doorknob cap under the chassis for the second filter. So it doesn't match what they list here in the differences, because they list 0.001 microfarad, but what we had was a 0.00005 500 picofarad capacitor under the high voltage chassis, and I don't know what the value of the door knob capacitor was. So it doesn't quite add up to what they're saying, and also that was a 10,000 volt capacitor, not a 6,000 volt capacitor. So it's, you know, somewhat closer, not exactly, but at least there's a note here saying that yes, there were differences. Let me see some of the other differences here, but I don't see. There's another one too. Some models have a candle resistor, others have a wire wound resistor. We had the wire wound resistor under the picture chassis. We didn't have a candle there. So yeah, definitely some differences listed here, but I didn't see anything listed about that massive difference in the vertical circuit. And you think that they would have called that out because it's so different from the schematic. So I don't know whether they just didn't note it, or like if this is like a super early production run or like a super late production run and it didn't make it into the schematic, or whether someone was just playing around to see what would happen. I don't know. But anyway, I'm going to play around to see what's going to happen, and I'm going to change it back to what the schematic shows just to see if that makes any difference whatsoever. And if it doesn't, well, then it doesn't, and we know our problem lies elsewhere. So after redoing that entire vertical circuit, we do have some more vertical height now, which makes me happy. Definitely more than we had before. There is still some vertical fold over from just the linearity here. One thing that I did notice, but you see how the linearity in the middle changes at least, which isn't really what we were getting before. Before, when I turned this either direction, it would just like basically fold the picture over on itself. I don't remember if I showed that in the video or not. So this is having some effect on linearity. There's still some fold over here though, which I don't really like. Let's pull the sync tube out, just see what happens. So horizontal will stay relatively stable with the sync tube out. Vertical will not. It'll keep rolling. You see horizontal, stays basically where you put it. Vertical linearity, so the issue is the schematic calls for 1 meg control here, but we've only got a 500 kilo ohm one. So it could be part of the issue why the linearity adjustment isn't coming in. Turn the height down a little bit. I don't think it needs to be that high actually. Cabinet right around there, and adjust. See, now I can adjust the centering way down too, which before it wouldn't go that low. So that's definitely an improvement in the vertical circuit by doing that rewiring. So I don't know whether someone made that change at one point, or whether the factory decided to do it that way and it just never worked that well. I really don't know what the deal was with that, but it is working better now. Still not 100% where I want it, like with the fold over and everything. You can see the bright line there, that's also some fold over. Put this sync tube back in. Or if I can put it back in. I don't know why when it's back in, it knocks the horizontal out of sync. That's weird. Verticals. Maybe this is a bad too. Let me try the other one that I have here. Tried a couple different ones of these, and none of them worked particularly great. It's the same thing. It knocks the horizontal out of sync once the sync tube is in. And then we got this tearing again too. Yes. You can see how it's brighter there and brighter there because of the fold over issues and these bright lines in the middle though, I'm not sure if that's fold over or if that's at the top. You can definitely see it's fold overs. You can kind of see how the picture like wraps over on itself a little bit there. with the bright lines that run through like the middle of the picture, so now that's full over. None of these sync tubes seem to do any good. It almost seems like it's worse with the sync tube in, which I think we've been playing on this before and also discovered that. Like somehow the sync tube being in actually makes the sync worse. Now I have gone over that circuit, and there's like the resistors that are there are like not out of tolerance or anything. And there's no old capacitors in any of these chassis. So what exactly the issue is with the sync circuit, I'm not 100% sure yet. I have replaced the video amp tube as well. Got some supposedly new old stock ones to try in there. It's the same as the sync tube, and I've been trying. I tried one of the supposedly new old stock ones with the sync tube too, and same thing. Nothing seems to work that well there for some reason. And I've gone over the schematic, and it's now vertical syncing, but we still got this lump here. See how it's brighter there too. That's not syncing. So your vertical linearity is kind of, see, it's almost like it's worse with the sync tube in. So something is still weird. They got all these like bright spots, like bright streaks across. Let me pull the sync tube out. Looking at the vertical. Somewhere close. You see, it's somewhat better, like in the, the region where it's not squished. There's still some streaking there. It's like bright streaks across. I'm not sure if that's like non-linearities in the vertical circuit or that's something else going on there. So, it's somewhat better, but it's still not where I wanted. So I'm going to do some closer inspections of the sync circuit to see if I can figure out what the heck's going on here. Maybe try a couple different tubes, just see if there's any difference at all between them. So far I haven't really noticed anything. But anyway, at least we've seemed to have solved the vertical height problem, so that's good. I'll continue playing all this and see what we can discover next. Okay, so I think what I'm going to do is put this project to the side for a little bit. What I kind of want to try next is some different 6S and 7 tubes in the oscillator circuits. See, the horizontal is not bad. This is with the sync tube pulled out, but the vertical, I'm still not happy with it. I want to try different tubes in the vertical oscillator circuit. Additionally, we still have the issue with the sync tube. When I put that in, it still gets like super whacked out. So part of the problem could be that it needs alignment. It definitely does need an alignment. There's a double peak in the sound in the video. Let me so you can hear the sound there. So you can see so the sound stays good. That whole distance, even when the video turns to crap. Now the sound goes away. And now the sound comes back. So that's not supposed to happen. There's supposed to be like a definite peak on the fine tuning. That's me adjusting the fine tuning, by the way. There's supposed to be like a definite peak of the sound in the video together, and we don't have that. So definitely alignment issues. As I mentioned before, it's written on the tuner chassis that some of the receiver tubes are weak, so that could definitely be a factor. I don't know if that would cause our sync issues. It could theoretically, and there's variations in the amplification of the video, like if at some point in the picture the IF is giving more amplification or less amplification, theoretically there could be like some sync pulses are stronger than others. Like I don't know if this would actually happen, but it's just my guess as to what might be the issue and why the picture gets so much worse with the sync tube in. Let me pop it in actually and see if I have the right one. A couple of tubes laying here, so this would be the one probably. I think that's not the one. One of these tubes here. This is the one, this one's hot. See if I can pop this into the door. Probably not, so we're going to turn on the light for a minute. Pop this in. Now it's in. And now the picture gets all whacked out. Of course, I'm probably not tuned on it right, but notice how the horizontal sync is worse with the sync tube in. You find that kind of amusing. So what I'm kind of wondering, and I'm not sure if this would be possible, but you see how there's like this bar where everything's out of sync? I'm wondering if like at that particular point in the picture, like for whatever reason, the sync pulses get weaker, either because the alignment's out or because some of the IF tubes are weak or some other reason that I haven't thought up yet. But if the sync pulses get weak at that particular point, that could be why it's losing sync there. I'm also not sure how much effect the sync pulses have on like advancing the oscillator. Like if you get a stronger sync pulse, does it make the oscillator, start its cycle a little bit earlier or later? I'm not exactly sure about that either, but that theoretically could be the issue. Like as far as like the vertical, fold over, which this will get worse as it warms up. It usually does. Right now it's not like super terrible. Like as far as the vertical fold over issue, which usually gets worse as the sync tube warms up, and see how the vertical goes out of sync there. So if there's for some reason like certain sync pulses are not being amplified as strongly as others, like if there's if there's like some portion of the video that's not having its sync pulses amplified as strongly as others, if that would cause this rolling effect here where the vertical goes out of sync and the horizontal goes out of sync sometimes. Not sure. So we get these white stripes like that. So I'm not sure if I'm kind of thinking that that's like a little bit of vertical fold over there, like these white stripes here. Not exactly sure, but anyway, so I'm gonna put this at the side for a little bit until I can get some cheaper 6S7 tubes, because I'm not paying the $40 a tube that they went on eBay. So I want to get some new 6S7 tubes, and I also need to get the proper equipment to do an alignment on this because I don't have a proper alignment generator for this thing. So until either of those two things happen, or probably should both happen, we're going to put this to the side. The picture itself is actually not bad. It's nice and clear and I can get good focus on it. It's just the deflection and sync that's causing an issue, and more so the sync, because when the sync tube isn't in, the deflection really isn't that bad. But yeah, you can see we're getting our stripes there, and then there's some noise that travels up the picture, so it's getting a little bit distorted on the side there. But anyway, that's going to be about it for this video. Next video will probably be about something else, unless I have a brilliant idea that solves everything, which is unlikely. But for now, we're going to put this to the side. at least I know that the tube will produce a picture, and that, you know, the important components like the power transformer and the high voltage oscillator, all that seem to be good. You see there, it got really distorted. And you see there's a bit of distortion there. So like what I'm wondering is, like this dip here, there's a little bit of a bulge there and a dip there. Like I'm wondering if for some reason the sync pulses in that area of the picture aren't getting the same amplification as the sync pulses like in this area where it's bulged out, or vice versa. And for whatever, if that could be happening, if that's causing like the oscillator to start a little bit sooner in the dented in area, well, now it's too early for me to point out a piece, but the area where it's dented in, like here, I'm wondering if the oscillator is starting a little bit sooner here and starting a little bit later here, and that's why it shifted over. Not exactly sure, but anyway, I think that's going to be about it for this video. There should be more videos about this eventually, just not right now. So anyway, I had fun working on this thing and seeing like how far we could get with it, and I think we got pretty far, but there's still quite a ways to go. So that's going to be about it for this video. I hope you enjoyed this video, and thank you for watching.